space M2Q with gradical form determinant and H be the J spin group of W. For integer n, we define the lattice Ln to be the submodule of M2Z with n dividing C. So Ln is stabilized by the open contact group in Zn. Let D be the gross mapping of positive two planes in V. So as already seen in previous talks, the pair HD is a Shimura datum, and the complex points of the Shimura variety with level K0n are isomorphic to product of modular curves with level gamma 0n. Let Di be negative fundamental discriminants and satisfied Hegner condition, namely the prime factors of n are split in both imaginary gradical fields with discriminant D1, D2. So let K is a composition field of K1 and K2. We suppose K is a CM field, and then it contains a unique real gradical subfield F, and we define the Hecke characters Chi, Chi1, Chi2 to be by the relative gradical extension K over F, K1 over Q, and K2 over Q. Let U be the F gradical space with the gradical form norm over squared D. Let the maximum torus T be the inverse image of the restriction of SOU from F to Q in T in H, and denote the embedding from T to H as L. So for Hegner points tau 1, tau 2 with discriminants D1, D2, so the same cycle Z tau 1, tau 2 is the summation of double quotients of the maximum torus. It is a zero cycle defined over Q on product of modular curves. So this is the first half of my title, and next I want to introduce the second half of my title. So let F be a weakly holomorphic modular function with level gamma 0n and the trivial constant term. The Borcherds ellipse phi f of F is defined by the regularized theta integral of vector valued induction of F against one theta function defined by Borcherds. So this Borcherds ellipse can be written as the logarithm of a Borcherds product. So it is a meromorphic function on product of modular curves. And it has a product expansion, and is called the Borcherds product associated with F on product of modular curves. Now I can introduce our main theorem about the algebraicity of CM values of Borcherds products. Here are some conditions. Let n be odd and square free. Let CF be the Borcherds product on product of modular curves. It's defined over Z and with effective divisor. So for Hegner points tau 1, tau 2 with negative distinct fundamental discriminants and satisfied Hegner condition and are not both even, then the CM value of the Borcherds product is not an S unit when the maximum of the absolute values of D1, D2 is sufficiently large. Here S is the set of primes dividing n. The main idea of the proof is to realize Hilbert Eisenstein series and the Doyle-Naganuma lift of elliptic Eisenstein series. So let ISK be the principal series for the restriction of SL2 from F to Q. Given a standard section VHS in principal series, the Hilbert Eisenstein series EH is the average sum of VHS under the action of JF quotient BF. So it converges absolutely when the real part of S is sufficiently large, and of course is a Hilbert modular form. So let V be the direct sum of Q square and F. For Schwarz function on analytic points of V, let var be a Schwarz function on the analytic points of V. So as in previous talks, we can define the theta functions, theta V, JH var by V representations for the dual pair SL2 and O22. Given a standard section C in ISK1, we can similarly define the elliptic Eisenstein series EJ as so associated to the section C. Then we denote the theta integral of the elliptic identity series against the theta function theta v jh bar phi, and IH could see bar phi as to hint the two choice of Schwarz functions. So it is still a Hilbert identity series, and the convergence absolutely when the real part of S is not smaller than 0. So there is one special class of sections in principal series called the Zego sections. Zego sections are the image of the map under the image of the lambda map. So lambda maps one Schwarz function to an element in the degenerate principal series by taking values and 0. So elements in degenerate principal series naturally extend to elements in principal series, namely extend from S0 to all S in C. So for any Zego section phi in IS chi, and any integral, any positive number n, we can asymptotic Hilbert identity series by the Dorian-Naganuma lift of elliptic identity series up to one analytic factor Cs and one error term OSN. I want to show you one example. Let P be an odd prime and AP be Fp cube with gradical form determinant over P and HP be JL2FP. So let eta be the unique gradical character on Fp cross, and define the vector UP to be the average of EL under the action of H twisted by the gradical character chi. So here L is the isotropic vector 1, 0, 0. So when the discriminants Bi are odd and co-prime, so this incoherent Hilbert identity series of parallel weight 1, 1 can be realized as the Dorian-Naganuma lift of this elliptic incoherent identity series of weight 1 against theta function theta v jh bar phi. So for the prime dividing P1, bar phi P is given by the vector UP, and in other places is defined canonically. Such explicit realization enables us to know the D1, D2 part of the same values of Borcherds products, and leads to the condition D1, D2 being sufficiently small in our main theorem. So, yeah, thanks for your attention.